All right, so I see some of you guys joining the stream. You're welcome back once again to another live section with us on this channel. So if today is your first time on this channel, please do all to subscribe to the channel, like, and then share. So in today's video, we are going to look at differentiation. We are going to actually practice questions based on the concepts we have learned on calculus and specifically differentiation. So without further ado, let's get going. So as you can see, this is session 1 of our discussion on differentiation. Please do well to like the video, subscribe to the channel, and then share it out. Invite people who will be interested in this kind of tutorials to help them to actually excel in their academic journey. So let's get going with that. Sorry. So this is our first question. The process of finding a derivative of a function is known as the process of finding a derivative of a function is known as A, derived coefficient, B, calculus, C, differentiation, D, integration. So which of the following best meets the definition above? And that should be differentiation. That should be differentiation. That should be differentiation. So differentiation is the best possible answer to this question. So that is the differentiation. So when you find a chain between two quantities, we will say that we have differentiated what those two quantities involved. So let's take note of that. Question 2. The following can be referred to as the derivative of a function, except the following can be referred to as the derivative of a function, except, so for us to know that the function has been differentiated, we add what we call the variable or the letter D attached to that quantity. Say differentiate y, differentiate x, say differentiate a, differentiate b. It depends on the quantity we are actually into play with it, right? So if you are into x and y, then differentiate y, differentiate x. But if you are into, say, a and b, differentiate a, differentiate what b. All right, so you have, for example, dy over dx as one way of differentiating the function, or possibly f prime of what, say x. That's also another way to differentiate a function. Okay, or better still, changes in what, two quantities as written in words. But when you have a function of this form, then you haven't differentiated that function. It's still the same function actually. So here, the best option that will fit the definition above should be what, function f of x, and that should be the answer to this approach. So let's take note of that. I see some of you guys joining the stream. You're welcome back to our live session today. Thank you for joining us, and please do all to subscribe to the question. Number 3. Which of the following is true for the first differential of two quantities? Which of the following options is true for the first differential of two quantities? For the first differential of two quantities. So we have A, dy over dx, B, double prime of what, f, double prime of q, C, we have d squared y over ds squared, we have D, first prime, then the function with another prime x. So which of the following is true for the first differential of what? So if you are talking about the first differential, for example, if I have a function, say y should be equal to x. For me to find the first differential, it should be what? dy over what? dx. If it is in the form of what? F of x, the first differential is going to give us what? F prime of what? X. This is what we call the first what? Differential of what? Two quantities. So here, which of the options will actually meet it? And that's going to be option what? A. Differentiate y, differentiate x. So we take A and we are good to go. Let's move on to question number 4. The rule of differentiation, which says that the differential of two or more functions, which when combined will result in addition, is called the rule of differentiation, which says that the differential of two or more functions, which when combined will result in addition, is called A. Chain rule, B. Sum and differences, C. Product rule, and D. Quotient rule. If you have an answer to it, you can drop it in the comment section whilst I showcase your answer to others to understand that you have gotten the concept actually. So which rule actually talks about this, not the chain rule. Chain rule doesn't result in addition. Sum and difference, you know. So our quotient root is also no. So it's actually a product that results in what? Addition. For example, if I have, say, y is equal to what? V and u. At any time I differentiate, sorry. If I want to differentiate this function, okay, actually the end result is going to result to, it's going to be like differentiate x with respect to, it's going to respect to s actually, but remember v and u is possibly going to be the function of what? X. So this is how it's going to be. So when you differentiate, it's going to result to u differentiate v differentiate what? X, right? Plus v differentiate what? U differentiate x. So you realize that at any time you differentiate what? Quantities that are joined together as a form of multiplication result to what? Addition. And that's what we call the product what? Rule. So the product rule is actually what we are actually talking about here. So this is going to be a product what? Rule. But the one that results in division is what we call the quotient what? Rule. So product rule results, at the end of the day, results what? Addition. So let's take note of that. Okay, rest for saying that is C. That's great. That's product rule. Good. Differentiate the function with respect to q. Y is equal to q to the power of 3 plus 4q squared minus 25. So we are asked to differentiate this function. So we have y to be equal to q to the power of q plus 4q to the power of square minus what? 25. So what is happening here? So here we are differentiating y with respect to what? X. Is that okay? So in this case, you're going to have dy over what? dq, not x, please. It is dy over dq. So in this instance, it's going to be, so for you to differentiate, first of all, the power or the exponent is going to take the coefficient of what? The main what? Variable under consideration. So you will multiply the coefficient, sorry, the power by the coefficient of the variable under consideration or the quantity under consideration. So you have here to what? 3q, and you repeat what? The power again, subtract 1 from it. This is how we differentiate. Plus, so you have 4 here, that's the coefficient. So the 2 going to multiply the 4, okay? You repeat the q with a square and subtract 1 from it. In our differentiation class, we said that the differential of what? A constant will result to what? 0. So we have here to what? 0. So therefore, our dy over the q is going to give us 3q. Remember, 3 minus 1 is going to fetch us what? 2, okay? Plus 4 multiplying 2, you are getting what? 8. So you have 8. Then 2 minus 1, we are getting what? 1. So that's q to the power of 1. Minus 0 is same thing as for that. So we just ignore that. So therefore, we say that our dy over the q is going to give us 3q squared plus what? 8q plus 8q. So let's take note. So that's going to be option what? C. That's going to be option C. 3q squared plus 8q. 3q squared plus what? 8q. So let's take note of that. Question number 6. If f of x is equal to s cubed plus 2x minus 6, find f prime of 2. Find f prime of 2. So before we can find f prime of 2, we need to differentiate the function so that we can substitute the 2 into the differential of f of x. So we know f of x to be equal to f of x is equal to x cubed plus 2x minus what? 6. Okay, so here we are differentiating with respect to what? F prime. So you have f prime of x, and that's going to give us, so let's see. So here we have what? 3x 3 minus 1 plus, remember the power here is what? 1. So we'll multiply the 2 and you repeat it. 1. Differential of constant going to result to 0, so 0. We don't write it, or just show kind of. So f prime of x is going to give us what? 3x squared plus what? 2x. But we are asked to find f prime of 2. So what will be f prime? Therefore, f prime of 2 is going to give us, so whatever you see x, you substitute 2 there. It's going to give us 3 into bracket 2 squared plus 2 into bracket 2 here. Hey, sorry, here shouldn't be x. There's a mistake here. We want to rectify that and get it on, because differential of 2 is going to result to 2, not 2s again. So let's erase this so that we don't make a mistake in there. So here going to result to 2 actually, because we subtract 1 from here and we are getting 0. So we are going to get here 2. So plus what? 2 plus 2. So we can move on. Therefore, we say that here is going to give us 3. The square of 2 is going to result to what? 4 plus what? 2. Then 3 multiplying 4, what are we getting? 12. 12 plus 2, we are getting what? 14. So we are getting 12 plus 2, and then we are getting what? 14. So meaning that in a function f of x is equal to x cubed plus 2x minus 6, where we are asked to find f prime of 2 is going to give us what? 14. And that's going to be option what? C. That's going to be option C. So let's take note of that. If you have any question, you can drop it in the comment section whilst I read and explain concept to you for you to understand and appreciate it far more better. Question number 7. We have dy over dx is equal to what? X squared minus 2x minus 2. X squared minus 2x minus 2. We are asked to find the positive value of x when dy over dx is equal to what? 1. So we have dy over dx in terms of what? Its function to be equal to x squared minus 2x minus 2. And we have also been given in terms of its value. That is the turning point. In terms of its value to be equal to what? Or the change equal to what? 1. So mean that we have f dy over dx, or f prime of what? X in terms of its function and in terms of its what? Value. So if the function and value all having dy over the x, then mean that we can equate what? The 2. Is that okay? So this will mean that we have x squared minus 2x minus 2 should be equal to what? 1. Should be equal to 1. Should be equal to 1. So at the end of the day, we want to arrange this in a form of what? We want to arrange this in a form of what? Ax squared plus bx plus what? C, and that should be equal to 0. In the form of what? Quadratic what? Equation. So we will say that x squared minus 2x minus 2, the 1 will join the negative 2, that becomes a negative 1, and we equate everything to what? 0. Okay? So we are having x squared minus 2x, all right, minus 3, and that should be equal to 0. So here we come back to our method of factorization in terms of quadratic. So here it's very simple. You want to factorize this, you can use calculator to do that, or better still, you go by our old approach by first of all finding the two numbers which were multiplying. Going to fetch you what? Negative 3. Okay, sorry, which when multiply, yes, going to fetch you negative 3, but when add is going to result to what? Negative 2. You look out for two numbers which when multiply going to fetch you negative 3, but when added is going to result to what? Negative 2. So what do you think going to be the numbers? You can put it in the comment section whilst I bring it up. So I think that the two numbers should be equal to that of negative 3 and positive 1. If you side with me, you can give me a thumb up on the comment section, whilst we proceed in that line. So it is what? Negative 3 comma what? 2. So when you multiply negative 3 by 1, we are getting negative 3. But when you add it, we are getting what? 2. So meaning that we can have the whole of this expression as being represented as what? S squared minus S squared minus 3x, okay, my positive, sorry, plus what? X minus 3 should be equal to what? 0. This is a normal rule of what? Actually factorizing, but you can use calculator to work it out simple so that you're good to go. So at the end of the day, I will say that I have my x out here, I have another x inside, minus what? 3, okay, plus, so here should be 1. Now I have x minus 3, and that should be equal to what? 0. So I have x plus 1. So you see, you get the values back, x plus 1, then we have what? X minus what? 3, and that should be equal to 0. So at the end of the day, you tell us that we have x plus 1 should be equal to 0, or x minus 3 should be equal to what? 0. So at the end of the day, we'll say that x should be equal to negative 1, positive for 3, positive 3. But here we are asked to find the positive value of what? X. So therefore, we'll conclude that the positive value of x from this function, which is s squared minus 2x minus 1, having a value of 1, should be equal to what? Positive what? 3. Should be equal to positive 3. Should be equal to positive 3. Should be equal to positive 3. So we have option A as an answer, or whether you shade or you take, you are good to go. So that is question number 7. Now let's move on to question number 8. You're asked to differentiate with respect to x the expression y is, let me write one for you, y is equal to 3 over 4 x to the power of 4 minus 1 over 2 s squared plus what? 7. This is what we are asked to differentiate. This is what we are asked to differentiate. So to differentiate this function is actually very simple way to go. Once you know the rules of differentiation, it becomes so easy. So therefore, we'll say that our dy over dx should be equal to, so the power 4 will multiply what? The coefficient 3 over 4. You're going to have what? 3 over 4 being multiplied by the power of 4, and repeat what? The function, this variable again with the power, so x to the power of 4. After that, you subtract 1 from the 4. Then you move on to the next what? Variable, which is what? 1 over 2 s squared. So that 1, 2, the 2 will multiply in what? The coefficient of what? 1 over 2, and you subtract 1 from the power. So you have negative 1 over 2 multiplied by 2, and repeat it, s squared minus 1. From our differentiation class, we learned that the differential of a constant will result to what? 0. So differential of 7 is going to result to what? 0, because 0 is a constant. So you either ignore or you add plus 0 to actually follow the method of what? Answering your question. So therefore, we will say that 3 over 4 multiplying 4 x to the power of 4 minus 1, we are getting what? 4 will cancel 4, so we are getting what? 3x to the power of 3, okay, minus, then 2 half multiplying 2, you're also getting what? 1, because the half will cancel the 2, making it 1. So we are getting negative what? X to the power of 1, and we don't repeat the 0 again, okay. So that becomes our dy over dx. So for me to write far more better, we'll say that my dy over dx is going to result to 3x cubed minus what? X. In some options, they might actually go a long way to factorize this expression by saying that this can also be written as what? X into bracket 3x squared minus 1, something like this, and you see it as part of the option, and then you are good to what? Go. And you are good to go. So let's take it. So that's going to be which option? Based on our first answer, that should be option what? A. That should be option A. Whether you circle or thick, you are good to go. So that's question 8. Then we move on to question number 9. All the functions below are defined in explicit terms. When we talk about explicit terms, this is what we mean. For example, I have a function, say y is equal to 2x squared plus 1. This function is called in its explicit what? Form. By explicit, we mean that we have one variable on one side and another variable on the other side. By explicit terms, we mean that we have one variable on one side and a variable on the other side of the equation. Okay, but by implicit, we mean that we may have, say, x and y on one side, at the same time having x on the other side. This is what we call in its implicit what form. So by implicit expression or implicit what terms, you may have the two terms on one side, okay, being combined or joined in the form of multiplication or a product, and also have what the other term on the other side. This is what we call innate what explicit, sorry, innate implicit what term. But by explicit, we have only one term on one side of the equation, another term on the other side of the equation. So that is the difference between the implicit and then the explicit. So we are saying that all these functions are defined in explicit terms, except, so by explicit terms, we can say that A is in its explicit term, so that is out. Likewise, C is also in its explicit term, that is out, right? Likewise, D is also in its explicit term. But with B, you can see that we have 3Q on one side, but you also have what? We also have PQ, which are the two terms that should have been Q on one side and P on that, but that has been combined. This is what we call innate implicit word term. So we're saying that all these functions below are defined in explicit terms, except word B, which is not in its explicit term, but rather implicit word terms. So let's take note of that. This is what we call an implicit word function, an implicit function. Question number 10. Find the derivative of the expression. Find the derivative of the expression. So we have v to be equal to 3u squared over what? U cube. I see some of you guys joined the stream. You're welcome back. Please do well to share the video out. Like, if today is your first time on this channel, please do well to subscribe and then share the video as well. Thank you for joining us today on our channel. So we are asked to find the derivative of this expression. By this way, we are asked to differentiate what? The function v is equal to 3u square all over what? U cube. To do this, first of all, reduce what? The variable in its simplest word form. Reduce the variable in its simplest form. So by this way, we can say that v should be equal to, with our basis and the indices, we can conclude that if I have u square over u cube, I can apply my law of indices. So I will say that 3 u. So when it comes to what? Having the same base and we are dividing, we subtract what? The denominator exponent from the numerator what? Exponent. So that's going to give us what? 2 minus what? 3, right? So that becomes what? V should be equal to what? 3u to the power of what? -1. So I've reduced the whole expression in its simplest form to become 3u to the power of -1. Okay. So once I get this, now I can move on to differentiate this function. So I will say that differentiate v, differentiate what? U, and that should give me what? Remember, the power here is -1. So when it multiplies what? +3, we are getting this, right? U minus 1 is subtract 1 from the power again. So what are we getting out of this? So we have what? The v over what? The u, and we should be equal to -3 u to the power of what? -2. So for me to write this in its simplest form, I will say that sorry for that. So for us to differentiate this in its simplest form, let's continue. Sorry for that. That was a bit interaction that I need to sort it out so that we get it done in that way. So for me to write this in its simplest form, that becomes what? -3 out of what? U square, right? So if I have some, for example, like let's say 2x to the power of negative, I can write this as what? 2 over what? X. If I have something like, say, 3x to the power of negative 4, I can write this as what? 3 over what? X to the power of 4. So likewise, if I have negative 3u to the power of negative 2, I can write this as what? Negative 3 over what? U square. I hope that is clear. So this is what we're going to get when we differentiate what? 3u square over what? U cube. And that's going to give us option A. That's going to give us option A. So either you circle or you take, depend on the requirement, you are good to go. So let's take note of that. I hope you're okay with that. Let's move on to question number 11. Question number 11. If a point moves on the curve x squared plus y squared, and that's equal to 25, then at 0, 5 as a point, we are asked to find d squared y over dx squared. Should we go? So d squared y over dx squared should be equal to what? That's a question mark for us. So before we can find this point, we must differentiate what? This function, which is x squared plus y squared, which is equal to 25. So let's do that here. So we'll take it from here, so that we'll divide. So I have what? X squared plus y squared, and that should be equal to what? 25. Okay. So at this point, here, this is what I'm going to do. When I differentiate x squared, I'm getting what? 2x. Okay. When I differentiate y, I'm getting what? dy over dx. But remember, the y is what? In a group of what? Having a power of 2. So I'll follow the normal differentiation. Now I'll bring the 2 in front of what? The y, and I'll differentiate the y itself, which becomes what? Remember, once I differentiate, it reduces to what? 1. So I'm going to have here to be coming. Going to have here to be 2y, then I'll differentiate the first what? Y, which becomes what? dy over dx. Okay. And we know that the differential of constant going to result to what? 0. I hope you are getting what we actually want to put across here. So if I have y to the power of 3 and I want to differentiate, it becomes what? 3y squared. That's the first one. I'll differentiate, and we know that the differential of what going to result to dy over dx. Depend if it is x, then it's x. But if it's a different quantity, it becomes that. So that's going to give us what? 3y squared dy over what? Dx. That's what we are talking about here. So if I have y squared, it is 2y dy over what? Dx. And the differential of constant going to result to what? 0. So we don't bother ourselves on that. So therefore, let's continue from here. So that's going to 0. So we can therefore make dy over dx the subject. So what are we going to do? We say that dy over dx should be equal to, so here is positive 2x. When it joins the 0, it becomes for negative. So negative 2x. And then I will divide both sides by what? 2y. So it becomes what? 2y. So this is what we are talking about. So I first of all actually ensure that the 2 will join the 0, and that becomes negative 2x. And I will divide both sides by what? 2y. And I'm getting what? Negative 2x over 2y. Remember, I can also reduce this in simplest form by saying that I have dy over the x to be equal to 2 cancel 2. I'm left with what? Negative x over what? Y. Negative x over y. But that's not what we are asked to find. We are asked to find the squared y over the x squared. So once we are done with the first differential, we move on to differentiate this function what? Again. So we have dy over the x to be equal to what? Negative x over y. Okay. So this is what we're going to do. We'll do what we call a cross multiplicational approach. So we'll ensure that the y will multiply what? So this is out of 1. So the x will multiply negative, the negative x will multiply the 1, and the y will multiply what? Dy over the x. So I will say that y multiplying what? Dy over the x, and then 1 will multiply x, for which we are getting what? The same as what? X, negative x. Okay. So once we get to this stage, we are going to differentiate the function again. Remember, here becomes what? A product what? Rule. Here becomes a product rule. Here becomes a product rule. So I'll first of all hold the y, and I'll differentiate what? Dy over the x. After that, I will say that plus, and I'll come and hold the dy over the x, and I differentiate what? The y. That's what we're going to do actually here. So I'll hold the y, and I'll differentiate what? Dy over the x. So when I hold the y, when I differentiate dy over the x, that is second derivative, becomes what? The squared y over what? Ds squared. Okay. Plus, once I'm done with the differential of dy over dx, I'll come and hold dy over dx and differentiate what? Y. So I'll have what? My dy over dx, and I'll differentiate what? Y. Differential of y is going to result to what? Dy over dx. So I have here to be dy over dx. And I'm done with the left hand side of the equation. The left hand side of the equation. Then I'll move on to the right hand side, which is what? Negative s. The differential of negative s is going to result to what? Negative 1. I hope you know that, because it is negative x to the power of 1. So 1 will multiply this. I'm getting what? 1 by 1, and I'll subtract 1 from here. I'm getting 0 here, s to be 0, and we are getting what? Negative what? 1. A number to the power of 0 is what? 1. Okay, so I'm getting what? Negative 1 there. So once I'm able to arrive at this pace, then remember the values was given us what? 0, 5. Okay, so now let's see what we can do here. We know that our dy over dx here, dy over dx, we know that our dy over dx, where is it? We know that our dy over dx is what? Negative x over what? Y is equal to negative s over y, right? So all that I will do, whenever I see dy over dx in this function, I'll substitute what? Negative x over what? Y, and I'm good to go. And whenever I see y2, I'll substitute what? 5 there. And whenever I see s2, I'll substitute what? 0 also in here. So let's see what we will derive at the end of the day. So you are going to say that in this case, it's going to be, so that's what I'm going to do. I'll have my y, d squared y over ds squared. Let me have a 10 division for this so that we get it off. Plus, then I know here to dy over dx, and that should be equal to negative 1. So let's continue. So I should have rather do substitution. So let me erase it. Let me do this substitution first. And that will be far more better than that. So here, dy over dx is what? It should be negative x over y. And here to also negative x over what? Y. Okay. So I'm good with that. So once I'm done with that, then I'll come back to consider the points that was given. You know the x, the 0 represents the x, and then the 5 represents what? Y. Okay. So whenever I see s, I'll substitute 0 there. Whenever I see y, I'll also substitute what? 5 there. So we have here to be 5. Okay. D squared y over ds squared. Okay. Plus. So here too, I know that x is 0. So negative 0 out of 5. Negative 0 out of 5. A number multiplying 0 is for the same thing as 0. So you don't take that into consideration. And that should be equal to what? Negative 1. So the whole of this is going to result to what? 0. So we don't take that into consideration anymore. So I'll just take it off. So therefore, I'll have what? 5 d squared y over ds squared, and that should be equal to what? Negative 1. So I want to make d squared y over ds squared what? The subject. What will I do? I will divide both sides by what? 5. So therefore, my board is coming to limited. So let me use this approach. Therefore, when I divide both sides by 5, I'm getting d squared y over ds squared, and that should be equal to negative 1 out of what? 5. Negative 1 out of 5. And that is what you should be able to get when you differentiate x squared plus y squared, which is equal to 25. And that should give you option what? D. That should give you option D. So let's take note of that. 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 So question 12. Differentiate implicitly with respect to x. Differentiate implicitly with respect to x. So this is what we call the implicit function, as I was saying, implicit function. So we have xy plus what? 2y, and that should be equal to what? X squared. Okay. So here, the first xy, I'll first of all hold what? The x, and I'll differentiate what? The y. So I'll bring the x out. So when I differentiate y, it becomes, so since I'm differentiating with respect to s, it becomes dy over what? Dx. Assuming we'll say differentiate with respect to a, that becomes dy over what? A. So please, let's take note of those simple issues or rules there. So I'll hold x and then differentiate y. That becomes what? Dy over dx. Okay. Plus, since the product, I'll bring what? Plus. And I'll come and hold the y, and I'll differentiate s. So differential of s is going to result to what? 1. So by this time, you should be able to differentiate without the subtraction and those kind of stuff. I mean, that is what we need to know. And then plus, so here the power of y is just 1. So I will say that 2 dy over what? Dx is equal to the differential of x squared. I'm getting what? 2x. I'm getting 2x. So you're asked to find what? Dy over dx. So how do you, so at this point we make dy over dx what? The subject. Is that okay? So I will say that I have my x dy over dx plus 2 dy over dx, and that should be equal to 2x. Remember, you have y multiplying 1 is the same thing as what? Y. So minus what? Y. Minus y. Minus y. So I don't know, I do what we call factorization in this approach. I'll do factorization. I'll factorize this function by bringing the y over the x out and then finding the bracket between the x and then the 2. So I will say that dy over the x into bracket x plus 2, and that should be equal to what? 2x minus what? Y. So I will divide both sides by x plus 2. Divide both sides by x plus 2. And what am I getting? I'm having dy over dx, which is equal to what? 2x minus y over x plus what? 2. And then I am done. I am done. So that is the implicit way of differentiating what? A function. That's the implicit way of differentiating a function. I see some of you guys joined the stream. You are welcome back. Please do all to like the video. If you haven't subscribed to the channel too, please do all to subscribe to the channel so that we all get engaged. If today is your first time on this channel as well, and share it as well to friends so that they can also get a benefit to learn with us online. So thank you for joining in. Let's move on to the next question. Question number 13. We are asked to find the derivative of the function f of x equal to negative x squared minus 4 cos x minus 4 cos x. So when it comes to differentiation of trigonometry, let me give you a simple rule. At any time we differentiate sine, the differential of sine x, okay, will result to what we call cos x, right? And the differential of cos x will result to what we call negative sine x. Let's keep this simple differential for trig. Differential of sine will result to cos x, and differential of cos x is going to result to negative for sine x, right? So once you get this, we are good to go. So let me go so that I can have some space for the calculations. So here I have what? F of x, and that should be equal to negative 8x squared minus what? 4 cos x. Okay, so at this point f prime of x should be equal to, so I differentiate term by term. So here it's going to give me what? 8 multiplying 2 x squared minus 1 minus, so remember this is a product rule, negative 4 cos x. So I'll hold the 4, differentiate the cos. So 4, bring it up, and I differentiate cos x. We said differential of cos is going to result in negative sign. So I have what? My negative sine x plus. And then once I'm done with the differential of cos, I'll come and hold the cos x and I'll differentiate what? The 4. So differential of constant is going to result to 0. And I have what? My cos x repeated. Okay. So any number multiplying 0 is into 0. So we don't take that into consideration. So therefore, we say that our f prime of x is going to give us what? Negative 16x. Okay. For 2 minus 1 will give us 16 minus. So we have negative 4 multiplying negative sine x, and we are getting what? Positive 4 sine x. Negative, negative, when it meets, it becomes what? Positive. It becomes positive. So this is going to be our final answer to that, which is negative 16x plus 4 sine x. 4 sine x. And that's going to give us option what? C. If that is right, that's going to fetch us option C in that line, or you think. It depends on the approach that we are dealing with. Question 14. Given that y is equal to, here's what we call using the chain rule approach, but we have a simple way to do this without stressing yourself by using the chain rule. Given that y is equal to 2s cubed plus 2s squared plus 1 all to the power of what? 5. So we are asked to differentiate what? This function. We are asked to differentiate this function. So how do you differentiate this function? Very simple. So when it comes to higher derivatives or higher powers, first, to differentiate this kind of function, you first of all follow the normal rule by differentiating the power, right? So you say that dy over dx should be equal to, bring the 5 here to multiply the coefficient of what, the whole variable, the whole term under consideration, right? After differentiating the power, then you come back to differentiate individual terms in the bracket. So I'll differentiate 2s cubed, for which I'm getting what, 6s squared, okay, plus, and also differentiate what, 2s squared, for which I'm getting what, 4x, right? The differential of constant going to result to what, 0, so I don't bring that into consideration. So after differentiating the power and the terms in the bracket, that's the second step. So you first of all differentiate the power by using the power to multiply what, the coefficient of the expression, and the second, you differentiate the terms in the expression individually. And the third step is that after doing the next or the previous steps, the third step or the final step is that you repeat the whole expression again, which is called to what, 2s cubed plus what, 2s squared, okay, 2s squared plus 1, and then you have your 5 and you subtract 1 from it. That is the third step. So once you are done, then you tell us that in summary, you have dy over dx to be equal to 5 into bracket 6s squared plus what, 4x, okay, bracket close, 2s cubed plus 2s squared plus 1, and that should be the power of what, 4, and then you are done. This is the simplest way to differentiate functions of higher derivative or higher derivative kind of functions. All right, and you are good to go. So you differentiate the power, differentiate the terms in the expression individually, and after that you repeat the whole expression and then subtract 1 from the power, and then you are good to go. So this is going to give us option what? So let's see which option that meets this criteria. We have 6s squared plus 4x, right? So the a is out. A is out. Is B also pad? I think B and C, no. C, D is also out, rather. D is also out. C is also out because you don't have 5. Remember, the D is having 2, so you need to be careful here. Huh. So here, we will take what? B as the best option for the derivative. So, given that y is equal to what? 5 with our expression e to the power of 3x plus sine x. So how do you differentiate this kind of function? This is going to be our last question so that we get it off here. So we'll say that I have y to be equal to 5. I mostly call this at e. Line e is on the calculator. You see on the calculator, it has a value actually. To the power of what? 3x plus sine x plus sine x. So at this point, if I want to differentiate dy over dx, I'm going to differentiate them term by term or individually, okay? So when it comes to differential of what? Exponents with the e having a function on top, you first of all differentiate the function on the top of the e. I call that e for easy of understanding. So actually that's a name, but I'll bring that name later on. So you differentiate the function on top of what? This symbol, okay? Right? So when you differentiate 3s, you are getting what? 3. After that, use that 3 to multiply what? The coefficient of that this symbol under consideration. So when you differentiate 3x, what are we? You are getting 3. So 3 multiplying 5, you are getting what? 15. So once you are done with that, you still repeat this function e with it what? Power, right? So that becomes what? This line e with 3x, all right? So this is how we differentiate. Plus, and we said the differential of sine is going to result to what? Cos. So we have what? Cos x. So let me give you a typical example too. If I have, say, 6 with a symbol 3, let's say, let me take a different, let's say 3s squared. In this case, when I differentiate this function, 3s squared, I'm getting what? 6x. So that becomes what? 6x multiplying 6, and I'll repeat what? The e with a 3x squared. And I'm getting what? 36x 3, the e with a 3 what? S squared. This is how we differentiate this kind of function. So if I have, say, e with, let's say, 4x, it becomes what? Here the coefficient is 1. So when I differentiate 4s, I'm getting what? 4. So it becomes 4. Then I repeat this, 4s. This is how we differentiate this exponential kind of functions. Exponential kind of function. So let's take note of that. Okay. So We'll be glad to end it here for today. And we'll continue next time where we look at other rules when it comes to applications of differentiation and other related issue. So if you're blessed with this video, please do well to like the video and then share it out so that others can also get the benefit. And let me also give this quick announcement. We have started our online registration, our paid masterclass revision, or our paid masterclass or a class section with our students who are ready to learn under our mentorship or learn directly under my mentorship. So if you want to enroll for our regular classes, go for 180 Ghana cedis, and for you're going to have 8 meeting sessions with me within a month. It goes for 180 Ghana cedi to have a regular 8 meeting session with me directly, where I take you through the course that you will enroll based on the course that we discussed on this channel as well, to actually further improve your performance and other for you to actually excel in your examination. So that is what we have for now for you. Aside, you can also visit the channel to watch more videos on this channel based on what we have covered on the content. But if you want a full version or a full tutorial videos pertaining to the course you want to enroll, you actually enroll with 180 Ghana per month, having 8 meeting sessions within that month, and then you get all the content for that particular course in that line. So let's take note of that. Okay, I see some comment coming in here. Response says C. Oh, that question. Okay, maybe probably a different question altogether. Then Bema Lauren is saying that please repeat the question 7 by how? You mean I should explain? I think I explained that you were okay. Or I should kind of, sorry. Question 7. Question 7. This is the question 7. So you can check through and then watch, you'll be okay with that. We're having the function, we're also having what? In terms of its value. So when the function and value are the same, you equate the two and then you solve for x in that line. Okay. Always saying, yeah, okay, sure, that's good. The question 7 again. Okay, I have repeated again. So that is also Michael. Then we have Joseph Benjamin. He's saying that, is there any simple way to answer question 11? Oh, Marty, we have a number of ways to deal with it, but I think that is the best approach to actually deal with question 11, and you can't skip 2. You must go through this simple process to get it off. So first of all, differentiate. This is what we call the implicit form of differentiating the function, and then you are good to go. It's actually very simple. Just take your time, differentiate them step by step, and then you get it off in that line. All right, so thank you once again for joining today's section. I'm grateful for having you here. So those who are watching the playback, please do well to actually subscribe and then like the video and share it out to our friends. So I'll catch you up next time while we bring live videos like this to you for you to appreciate the content and the course you are learning on our channel. So I will see you next time. Bye-bye.